Tonight we start our new unit on logic, which is about reasoning and I guess proving things to be true, which is something that we're going to have to do a lot this year in geometry. So some people like this unit a lot because it's really a lot less math than you typically see, and it's kind of a lot more English words, things like that. Not necessarily an easy unit because you will have to think critically and problem solve, but there is a lot less actual calculating and things like that. All right, so the first thing we need to know when we're talking about reasoning and proof is what a conditional statement is. And a conditional statement is a statement where you state that an event will only occur if a certain condition is fulfilled, thus the name conditional statements. So they're usually written in the format of if then. So if something happens, then something else will happen. And this is the symbol for a conditional statement. So the first part leads to the second part. So for example, if you clean your room, then you can go to the movies. That first part of the sentence, the if part, we call the premise. It's also known as the hypothesis, and it's represented symbolically by the letter P. The second part of the statement is called the conclusion, and it's represented by the letter Q, not a C, I think primarily just because Q follows P in the alphabet. So the condition in this case, or the premise or the hypothesis, is cleaning your room, and then the outcome would be you go to the movies. So we also have these things called related conditionals. We have the converse, the inverse, and the contrapositive. So each of these take our original conditional statements and change it in some way. The converse, and I've underlined the CO because it helps me remember that the converse changes the order. So instead of starting with our P and resulting in our Q, now we're going to say we're going to start with our Q and result in our P. So the case of if you clean your room, then you can go to the movies would now be if you can go to the movies, then you cleaned your room. So we change the order of our premise and our conclusion. Notice that the if and then stay the same. They are not part of the premise or the conclusion. It is the components of the conditional statement. The other thing to note is that conditional statements, while they are in the format of if then, they don't have to be. So you could reword this statement as all children who clean their room get to go to the movies, and it's stating the same information that you only go to the movies when you've cleaned your room, but it's not written in an if then statement. So you have to keep that in mind. Sometimes it's not always going to be written that way. You'll need to kind of be able to translate it. Um, the inverse is where we take our conditional and we negate or take the opposite meaning of our premise and our conclusion. So I think of it as IN or inserting not. If you do not clean your room, then you cannot go to the movies. This symbolically is the symbol, this squiggle for not. So not P implies not Q. These two, the converse and the inverse, are logically equivalent. So in other words, anytime you have your converse, it means the same thing as your inverse. The final related conditional, well, actually, there are two more, but this one is called the contrapositive, and it essentially takes the converse and the inverse and combines them. So not only do we switch the order, we also insert not or negate our two sentences. So it would be if you couldn't go to the movies, then you didn't clean your room. The contrapositive and the original conditional, those two are logically equivalent as well. So these two are logically equivalent, and our original and our contrapositive are logically equivalent. Okay, finally, I made this up here already. Truth value is a statement that's either true or false. So that's fairly easy to keep in mind. So basically, the only time that a statement is false is if both the premise and the conclusion are false. Otherwise, the statement's true. And the biconditional exists if both the original conditional and the converse are true. The biconditional is another, our final related conditional. It's a little bit different. It uses this double-headed arrow, which basically stands for the terms if and only if, which you can abbreviate using IFF. So we would take our P and our Q. You can go to the movies and join it with the if and only if you've cleaned your room. You can go to the movies if and only if you've cleaned your room. And that's true if both, again, the original conditional and the converse are true. The final thing you need to jot down is all of the symbols that we're going to use to abbreviate and represent words. These are going to be tested on the quiz and the test, so you're definitely going to want to make sure that you know these. We talked about some of them. Some of the other ones are new, and you'll see them kind of tomorrow in class. And come in with any questions.